So today, two review topics. What number is some fraction of the way between one number and another number? And reviewing how we calculate the distance between 2 points, x1, y1, and x2, y2. So the name of the number problems will look something like this. When we do these, I do not require that you draw the number line. I'm just putting it in there to help us think about what is this problem asking us to figure out anyway? How does it work? Why do we need the letters that we end up having in the formula? So let's start with a look at what's going on here. They say start at 4 1/3, so we're going to start here. And then we are going to go toward -2 2/3. So we're going to the left. And -2 2/3 is about right here. If I start over there on the right and I go about 2/5 of the way, let's see, that's less than half. So I don't know, somewhere kind of sort of in here somewhere. Look about right in terms of something that makes sense. So we ought to end up somewhere in there. If we get an answer that's 10.5, that's not even between those two numbers, we've done something wrong. We've gone the wrong direction. Or if we end up with something that's -7, that doesn't make any sense either, because we're only going less than half of the way between there. So we want our number to make sense. Who thinks she remembers something of how this formula works? Other classes have kind of had to put some ideas together from different people. Maggie, what are you thinking? And you're on the right track, but we have too many things running around in math that start with L, that start with S, that start with F. If we use an S, is it the start? Is it the smallest? If we use an F, is that the first? Is that the fraction? And so if we just try to memorize the letters, and you're very, 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 very close, so good job with that, we're going to get some of the problems wrong because they're not going to match up exactly right. So we want to start at 4 1/3. So we are going to take 4 1/3, and then we are going to go somewhere with it. We need to take 2/5. And our formula was going to be that our new number equals S plus F. And now for this next part. If I take 4 1/3 minus -2 2/3, if I take the large one minus the small one, that looks to me like I'm going to get a positive number. And if I take 4 1/3 plus 2/5 times a positive, I'm going to the right. I'm going to end up with one of those numbers that does not make sense in this context. So this is not really largest minus smallest here. It is start minus, and I can't really say finish because I'm going to be doing a fraction here. I can't have F for both of those. So start minus the last is what I need here. I do need how far apart are 4 1/3 and -2 2/3. So I do need to subtract them. But it's the, I'm sorry, I wrote that wrong. It was last L minus S. Last minus start. If we always do it, the last minus the start, we'll get the plus or the minus correct in that. So in this case, I need to do not 4 1/3 minus 2 2/3, but -2 2/3 minus 4 1/3. Now I will have a negative in there. So if I take 4 1/3 and then do something negative, I'll be going into the left, which is the correct direction. So does that make sense? Sorry, I miswrote that at first. Does it make sense with what I'm saying now? But again, we have too many things that L can be and S can be and F, so we want to think about it in the context. Where do we start? Plus a fraction. That part we usually do pretty well with. And then we want the distance between them, so we do need to subtract them. But if we're going to be going to the left, we need to make sure that ends up being a negative. If we're going and starting on the left and going to the right, we need to make sure that starts out with a positive. So what we get here, 13 thirds plus 2/5. Can you guys just put together negative 2 2/3 and negative 4 1/3 and tell me what we have, or do I need to get those into improper fractions? Negative 7, negative 21/3. So everybody's okay if I just say negative 7 there? So now I have thirds and fifths. What does my common denominator need to be? So I need to multiply by 5 over 5 and by 3 over 3. So let's see, I have 65/15 minus 6 times 7 minus 42/15. So I have 23/15, 1 and 8/15. Does that make sense with my number line? Yeah, I drew my arrow just a little bit too long, it looks like, but I guessed about right, somewhere in there between 1 and 2. So my answer makes sense in the context. So to recap, here is the formula that we're using. And you may do better with the new number is the start plus the fraction, and then for the distance we are always going to take the last minus the start. Start will always be the number where we say from. Last will always be the number where the problem says to. What is some fraction of the distance or fraction of the way from one number to some other number? So as long as we keep straight what those L's and S's and F's all mean, by thinking about the context, we should be okay. I won't go through another one with you since we just did the last one. It's just a matter of plugging in, but keeping straight what means what. Our other formula for today, our distance formula, if we have 2 points, x1, y1, and x2, y2, and we want the distance between them, our formula comes from the Pythagorean theorem, where one side would be x2 minus x1, and another leg would be y2 minus y1. So then the distance would be one side squared plus the other side squared, and then take the square root to get just the distance, not the hypotenuse squared. If you can remember that it's from the Pythagorean theorem, that should make it easier to remember that plus sign that is in between there. It does not matter which point is x1, y1, and which one is point 2. Suppose I had x2 minus x1 and I got 3. I square it and I have 9. But if I did it the other way around, I would have negative 3, and square it, I'd still have positive 9. So everybody okay with these two formulas? Let's review using the distance formula. First, you guys real fast do this in your notebooks. Just plug the numbers into that formula that you just copied down that you've been using for the last couple of years. Was Algebra 1 the first year that you had that? I know you at least had it then. So just review, hopefully, for you guys. So plug in. Some of you will do the one on the left minus the one on the right. Others will do the one on the right minus the one on the left, and everybody should end up with the same final answer. Should be getting pretty close to your answers. I see several of you putting those pencils down. Okay, shout out for me. Square root of, what you got? 74. Let's see if I can manage to get that. So if I took 2 minus the negative 3, I would have 5 squared. And then if I took 5 minus the negative 2, I'd have 7 squared. And 25 plus 49 is indeed 74, and we can't reduce that. 2 times 37, those are both prime. So very good when you've got numbers. The new thing that we're going to do a little bit with this is to come up with a formula. What if one of the points was numbers and the other one was letters? Coming up in a lesson real soon, we're going to start coming up with an equation for a line by using something called the locus definition. And we're going to be, we'll get to it coming up, but we're going to have to be able to do this kind of a thing. So we simply say that the distance is the square root of, and then we plug in x for either x1 or x2 minus 3 squared plus y minus 4 squared. And it is not going to matter whether we do it that way or 3 minus x squared plus 4 minus y squared. So right now, if you have this in a problem set, you can stop right there. But these are equivalent. When we do that lesson coming up real soon, we're going to have to be expanding these out to see if there's some terms we can combine. Not going to be a lot we can combine, but we'd have x squared minus 6x plus 9 plus y squared minus 8y plus 16. And what can be combined in that? Only the constants. So we'd combine it like that. If we had done it the way of the one on the right, we would have had 9 minus 6x plus x squared. Same thing, just a different order. Then we would have had 16 minus 8y plus y squared. So we'd get the same thing either way. So any questions on these formulas? Then I am going to stop us there for today, and we will work on a couple of the homework ones together.